Hey, this is Don from Padlock Technologies again with another video. We're going to talk about MPLS TE. Got a question about what that's all about and, from a theory perspective, how that works. So we're going to go to the blackboard here and we're going to actually talk about the theory of MPLS TE, and then I may demo it in a lab or so, but at least let's get the theory out. So when we get to the lab, it kind of makes more sense, right? So let's get to the whiteboard. You know, I like doing my titles here. So we got to do MPLS TE on this one. And I'm going to do an extra TE. Now, when you are learning MPLS in CCIE studies, right? This is when you really start learning about MPLS. They teach you one specific form, right? Um, which is just normal MPLS, and they only teach you, L3 VPNs. They really don't go into L2 VPNs, which could be, regular X Connect or, EVPN is one. Then you got VPLS, then you got VPWS, which is technically X Connect, but they just call it VPWS. But you don't learn any of those. You really only learn MPLS L3 VPN. Now, what's the difference with MPLS TE? So the key thing here to remember with MPLS TE is this is source-based routing, okay? Now, the reason why they call it source-based routing versus, destination-based routing is your basic IP networking, right? Everything is based on the destination. And the key is per hop, we look into the routing table and we say, okay, do I have a route to the destination, right? That's what dictates the routing function. With source-based routing can dictate what routers I actually want to go to, right? Now, there's two ways to do this. There is, make sure I'm clear, there's dynamic, and then there's explicit, all right? So there's dynamic and explicit. So dynamic is just auto-announce the tunnel. Tunnel finds, it looks at the topology information, and then it figures out a path to get there. Explicit is when you specifically say, I'm going to router A, B, C, and D, or I'm going to B, C, D, and Z, or I'm going to whatever. You're specifying the routing, right? And that's why it's called source-based routing, because there's a concept here called head-in and tail-in. So that's another thing here. There's a couple things that we're going to go from a concept here. So there's head-in, which is the ingress router, and then you have the tail-in, which is the egress router, all right? Now, this is all still PE to PE communication. This is MPLS in a nutshell is just PE to PE, right? It's always going to be PE to PE. So this is just another flavor of PE to PE communication or routing, and it uses a specific thing called CSFP, right? And obviously you need to use a link state protocol for this. So what link state protocols are you going to be using? You're going to be using OSPF or ISIS. Which one's easier? ISIS when you learn about ISIS, but since you kind of get blitzed and beat over the head with OSPF, you can also do this with OSPF as well. But if you're ever going to try to talk to or go to the service provider side of the house, you need to know ISIS. And even, now with the campus network with SDA, you still need to go and learn a little bit of ISIS, right? So you need this because the link state protocols do what? They have topology and reachability data, right? Reachability information. Whereas distant vector protocols only get reachability, but you need this topology information because MPLS TE, not only does it run SPF, but it runs a certain flavor of SPF, which is called CSPF. And this is constraint SPF. That's what the C is for, because the constraint is going to be based on what you define as a constraint in the algorithm. So you can say, give me a path that has at least 1 gig of bandwidth available, right? And when you get that 1 gig of bandwidth available, CSPF is going to run the SPF algorithm on the graph, and it's going to see, okay, based on what I'm seeing here, since I know everything in the topology, and remember, this is within an area, this is not into another area, because you're going to have to use another technique for that, but we're not going to do that. We're not going to talk about that in this video. but it's going to look at the topology information and say, okay, let me get all the links and let me see the bandwidth that's available in all of the links. And then when I find a path there, usually if you're going to do auto announce, when I find a path there, then I'm going to bring the tunnel up. If you don't match anything based on your constraint, that tunnel will never come up, right? And this is where you can do things like, hey, from a customer perspective, you can have, hey, you want certain amount of traffic, you want certain kind of features, you want certain kind of availability, blah, blah, blah. We can have you go down the gold path. You can have a gold path, you can have a silver path, you can have a bronze path, and you can send things through there because they have these things called infinity values that you can put on the link. You can also do tunnel E, this thing called TE values, because you got metrics and then you got TEs, right? And then you can do a TE value, and then based on the TE value, you can weave traffic in and out of your service provider network. But it's still all based on CSPF, right? The other protocol that you're going to use for labeling is RSVP, all right? Reservation protocol. Now, this is what's actually responsible for the labeling. Now, if you remember, like I said before, there are 4 ways to do labeling, all right? And let's go over that again for review. There's LDP, there's BGP, there's RSVP, which is what we're doing, and then there's segment routing. Now, I believe I already did a video on that one. I did a video on that one, and now I'm doing a video of this one. Service segment routing is a new technique that is very cool, and I will do a theory video on that before we go and do a video on, like a lab video on it, but I'll do a theory video on segment routing. It's really cool. It's probably going to be the new latest and greatest. Just think of it as like next generation MPLS. I really, the term next generation is overused, but this is really cool. So what you'll have is, let's have a head in here. We'll say this is the head in router, all right? And then we got routers in the middle. Now this is pretty simplified here, and this is the tail end. So when you initially do the tunnel, based on your constraints, the head end is going to send this message down everywhere here, everything here, called a path message, all right? Saying, hey, I need you to create a tunnel based on these constraints. And then the algorithm runs, everybody runs the algorithm and stuff like that. And then when the tail end gets it, it will send a reserved message back. So let's just say this is the path. So this will be the reserved message. Now, when the reserved message goes back, it also sends a label across all the paths. So this is reserve, label, RSVP, label, same thing. All right. And now that we got the label, when traffic comes in, now there's a couple ways you can have traffic go in. You can do PBR if you wanted to. You could do auto announce if you wanted to. You could do static routing if you wanted to. Now, auto announce will just automatically force traffic through the tunnel. It will actually put it in the routing table, so it will just force it. And it's not, I want to be very clear about this. Again, this is PE to PE. You will not get a route to the final destination. It will have a route in the routing table saying, hey, to get to this PE's loopback, you're going to go through, say, tunnel whatever, tunnel 0. If you made it tunnel 0, you can make it tunnel 1 if you wanted to. And then you'll see it going through these MPLS tunnels. You'll see the tunnels if you do the trace route. If you allow trace routing in your network, it'll go along that path. All right. What else is there? Because this is a brief introduction to MPLS TE. Oh, the other thing that MPLS TE does is it has this thing called FRR, fast reroute. Now you have 2 versions of fast reroute that you're going to technically learn. These are going to be local protections. So you're going to have link protection and node protection. So link protection obviously sounds like what it sounds like. and then node protection is the next up. So there's this thing called next hop, and then there's next hop, next hop. So technically in this diagram here, this would be, this link here would be next hop, and then next hop is up here. Okay, so link protection is here, node protection is here. All right, so this link goes down. Now, obviously, there would need to be another path to get here, like there would need to be another path here or something like that. So if this path went down, it would automatically switch over to here. And if, let's say, this was next hop, let's say this router goes down here, you would have another tunnel here to go this way, right? Because then technically this would be the merge point. In this design, this would be the merge point, right? Because this router went down, that's for next hop, if it was going this way. This router went down. Now I'm gonna have a tunnel here that says, okay, fast reroute this way. Get back onto the merge point, go to the TE. So this is the stuff that you can do with MPLS TE. Again, this is a broad overview of it because once we start diving more deep into MPLS TE, there's a lot more stuff that you can do. Very simple. There's things called forward adjacencies. Like you can make a tunnel, you can create a tunnel in any one of these routers. And I would say routers in the middle here are your mid routers. See, it's totally different, right? So when you talk about normal MPLS, you have your ingress PE, your egress PE, and then you have your P routers in the middle. That's normal, regular MPLS terminology. Then you have MPLS TE terminology that changes. Instead of saying ingress PE and egress PE, you got head end, tail end, mid routers. So these routers in the middle are actually called the mid routers. Right? So it changes the terminology completely. Same thing, just call it different, right? Now what you can do with the forward adjacency thing is you can go, I'm going to create a tunnel on this mid router here to this mid router here. And then the IGP, the underlying IGP, OSPF or ISIS, it will actually look like a directly connected link, right? And this is kind of the beauty of MPLS-TE because it does geographically, this PE or this mid router could be in a totally different section of the network. And if I do a forward adjacency, as long as I have reachability there, it looks like I'm directly connected and I could just send that path directly there from a IGP perspective. It'll look like a link in the underlay. And if you give it a better metric, it'll just take that route. What else is there about MPLS-TE? MPLS-TE is also used in ORR as well, optimal route reflection, which I showed you in the video. You can look in the channel and see optimal route reflection, where I actually did the theory, and I showed you in the lab what optimal route reflection is. But this is just another flavor of MPLS. Now, most of the time when you're going for your CCIE normal, your enterprise now, not route and switch when I took it, but it's called enterprise now, you're not going to do MPLS-TE. 99,999 points, like 5 nines, that you're never going to do MPLS-TE. You're going to do normal MPLS and normal MPLS L3 VPN, right? And obviously you need to know that stuff. This is more of a service provider thing. Segment routing is more of a service provider thing. Inter-AS L3 VPNs, more of a service provider thing. So that's option A, B, C, and D. D, most people don't know about option D, but I said that in my last video. So those are inter-AS L3 VPNs. You could do L2s as well, but you can get hairy with the L2s because now depending on how you're doing your L2 VPNs, you could run into a problem. That's a service provider thing. EVPN is a service provider / data center thing. What else is there? So if you're going for basically what I'm saying, if you're going for your CCIE, you're probably not going to do MPLS-TE, but knowing about MPLS-TE in the real world will help you, again, talk to your service provider when they're telling you stuff, hoping that you don't understand, right? This is more of a, hey, I'm teaching you so you can talk to your service provider. And again, this is still transport, right? This is the commute, the transport from bus to bus. So, or bus to bus station, or whatever, if you want to call it, right? Because the customer traffic is still going to be down here. So this is customer traffic. So this is customer still connected to the head end, right? And then customer down here. MPLS TE has nothing to do with the customer per se. It just has everything to do with how head end is going to get to tail end optimally, right? Depending on the links. That if all links are not equal, then you don't want everything going through, bad links. You may want to have a tunnel strictly going through your best links in your network. That's when you do MPLS TE. You force people to go through here, right? So that was MPLS TE in a nutshell. Very broad overview of MPLS TE. This is more of on the service provider side, but if you just love routing or networking, it's always good to learn something other than what's in your CCIE lab or requirements, because again, that stuff is just to pass the test. But in the real world, you better know more than just what's on the curriculum, because you will see things that are outside of that lab, right? And you better know how it works and functions, or you just won't. You'll pass the lab, but then when rubber meets the road and you get hit with a problem, you quickly understand what you don't know. I'm gonna tell you right now, I have two of them, two CCIEs. I can tell you right now, when I got my first one and I failed the first time, and that's when I was going to RTC. After I got that CCIE and I started going deeper into other tracks, I realized how much I did not know, right? The CCIE, and this is going to be a very wild statement, by the way. Most people don't understand this. The CCIE, yes, is a hard lab. It is a hard exam. You basically don't have a life for however long you got, right? Until you take it and pass it. But it is the starter track for everything else. Because you think you know IGPs, you think you know BGP, you go to service provider track and you'll find out how much you don't know about IGPs and BGP. So that's what I'm saying. It's a very hard exam, but it is the beginning, right? And I'm not saying that to deter anybody from getting the CCIE. Go get your CCIE if you love networking like that. If you like it, always try to get to the top. But realize that's only one mountain. And when you get to that mountain, you realize there's like 7 other mountains to climb, which is fun. But that was a side quest, by the way, for anybody that's going for their CCIE. Go get it, but just know it's a lot of studying past it. Don't just don't stop there. Keep going. This is Don from Padlock Technologies. I hope this video was informative. Don't forget to share, comment, like, and subscribe. Keep hitting me with the questions. Like I said before, you guys are helping my brain stay active with the questions, so I appreciate it. Thank you, and have a nice day.